What is derivative? What is derivative? Slope of tangent line of a function at a point is called derivative of function at that point. Now in this definition we see that derivative is slope of tangent line of a function. Now we try to prove this definition. Taking a function, let us take a function this f of x and taking 2 points a and b on the function. Now derivative is slope. Now we prove that derivative is slope of tangent line. So first we take here point a and b and then taking secant line ab. AB is secant line of function. Now first we find slope of this secant line AB. To find slope of AB, taking both the components, one component is along x-axis, the other component is along y-axis. So we get a right angle triangle AB. This is C. Let now according to this right angle triangle, slope of AB is taking this distance along x-axis delta x and taking this distance along y-axis delta y. So slope of AB is delta y over delta x. Is definition of slope is ratio of rise to the run. So slope of AB is delta y over delta x. This is delta y and this is delta x. Slope of AB is delta y over delta x. Now taking this point as x, then this point is point B on x-axis, point A on x-axis taking x, and point B on x-axis will be, since this is x and this distance is delta x, then this point becomes x plus delta x. Similarly, this point A on y-axis, taking y is f of x, and this distance is delta y. This distance is delta y between A and B along y-axis. Then this point is f of x plus delta x or y plus delta y. Now we find slope of AB, which is equal to delta y over delta x. Delta y over delta x, which is slope of secant line AB, is now this distance delta y. By distance formula, this delta y is this point minus this point, this point minus this point. That is f of x plus delta x minus this point f of x over delta x. means this distance by distance formula is this point minus this point. This point is x plus delta x minus this point x. So they will cut each other, and delta y by delta x is f of x plus delta x minus f of x over delta x, and this is formula of slope of secant line AB. So by this formula we can find slope of secant line AB, and this slope of secant line is called average rate of change or approximate rate of change of function f of x. This is called approximate rate of change or average rate of change. Why this is called approximate rate of change? Because if we choose these 2 points anywhere other on these other from these two, A and B, if we choose A and B here, then slope of that point may be different from this point AB, or if we choose AB here and here, from here to here, then slope of that AB may be different from AB, this one. Therefore this is called average rate of change or approximate rate of change. Now we find this slope of AB, which is secant line. Now according to definition we come to find slope of tangent line of function. Now tangent line, taking the same function f of x and taking points A and B, same like previous one. Now this AB is secant line, and according to definition slope of AB is delta y over delta x is f of x plus delta x minus f of x divided by delta x. That is slope of secant line. But now we want to find slope of tangent line. For that purpose we come here, this delta x, this is delta x. If you take this B closer to A, taking this point B1, then the secant line will come like this, AB1, and this from here to here, this delta x will reduce. Delta x will reduce to this. Again we take this B1 more closer to A, like here, taking this b2, then this secant line become like this, and this delta x from here to here, it will become, it will reduce again. Similarly, if we take b more closer to a, taking here b3, then from here, from a to b, from a to b2, b3, sorry, a b3 is the new secant line, and from here delta x reduces again. Now finally, if we take this point b more closer to a, or if we take it over point a, then the secant line become tangent line. It was secant line, it was secant, and finally it become tangent. So for tangent line, here we see that this delta x reduces, 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 and finally when we take this b over point a and the secant line become tangent line, then delta x approaches to 0. Delta x approaches to 0. Here, from here we see that delta x reduces, means delta x approaches to 0. So secant line become tangent as delta x approaches to 0. So for tangent line, the only condition is that delta x approaches to 0. So for tangent line, taking this delta x limit, delta x approaches to 0, delta y over delta x is equal to limit delta x approaches to f of x plus delta x minus f of x over delta x. So applying this limit is delta x approaches to 0 on both sides of this definition of secant line, we get slope of tangent line, since this one is slope of secant line, and applying this limit as delta x approaches to 0 on this definition, we get slope of tangent line. So this is slope of tangent line, and this is definition of derivative. This is definition of derivative. This is definition of derivative. That is definition of derivative is tangent line dy by dx means derivative of function y with respect to x is slope limit of tangent line. Delta x approaches to 0, f of x plus delta x minus f of x over delta x, or a prime x is equal to limit delta x approaches to 0, f of x, so x plus delta x minus f of x or delta x. So this is definition of derivative, which is also called first principle rule or definition of derivative.